Today's topic is thermodynamic origin on chelate effect. According to chelate effect, chelated complexes are more stable than the non-chelated complex. For example, ethylene diamine metal complex is more stable than the hexamine metal complex because amine is monodentate, ethylene diamine is bidentate ligand. If we see the equation of cadmium metal complex, here the 4 aqua molecules will be replaced with 4 amine molecules, right? So tetramine cadmium complex will resulted and 4 water molecules were released, right? If you see the particles of reactants, here number of particles are 5 and products number of particles also 5. 1 plus 4 number of particles are 5 for the reactants. Here also one complex and 4 aqua molecules number of particles are 5. That means the change in entropy is same for reactants and the products. That means the randomness has not increased. Random disorder is 5, here also 5. Therefore, delta S is same for the products and the reactants. If you see the second equation, here 2 ethylene diamine molecules were replaced with the aqua molecules. Okay, so here 1 and 2 ethylene diamine molecules. That means number of particles are 3. Whereas here 1 product complex and 4 aqua complexes are released. Therefore, the number of particles were 5. Therefore, the particles increased 3 to 5. That means delta S is increased. That is, disorder is increased. Right? So, change in entropy has increased. If you see the third equation, one triene molecules is going to replace with the 4 aqua molecules. That means here number of particles 1 and 2. Right? So number of particles are 2 for the reactants, whereas the product is 1 complex and 4 aqua molecules. Here number of particles were 5. Therefore delta S increased more. Okay. First complex is non-chelated complex and second complex is chelated complex and third complex is purely chelated complex, right? So in equation 1, delta S, that is change in entropy, is not increased. In equation 1 and 2, delta S has increased, right? If we see the thermodynamic expression for Gibbs free energy, it can be given as delta G equals to delta H minus T delta S. So, where delta H is change in entropy and it is same in all equations because in all products the metal to ligand bond, the donor is nitrogen only. Therefore, all these 3 equations can have metal to N bond same. Therefore, there is no change in entropy. By increase in delta S, there will be a decrease in Gibbs free energy, right? So, according to this equation, there is no contribution of delta H. Therefore, if we consider this, if we increase the change in entropy, there will be decrease in Gibbs free energy, right? So, if you see the Gibbs free energy again related to stability constant, right? Through the equation delta G equals to minus RT log K, where log K is stability constant. So, according to this equation, if the Gibbs free energy is decreased, the stability constant will be increased, right? So, if the free energy is decreased, the stability of the metal complex will be increased. Therefore, K will be increased. So that the chelated complexes are more stable than the non-chelated complexes by observing the values of equation 1 and 2 and 3 with Gibbs free energy and change in entropy values.